Hello, I'd like to talk about finding volume of solid using this method. Let's kind of review about finding volume of a cylinder. From your geometry class, you guys all learned how to find the volume of a cylinder. So if you remember from geometry, the volume of a cylinder is the area of a circle, which is pi r squared, times h, the height. So even if you look at this cylinder right here, the radius is right here, that's the radius. And now this becomes h. So the volume of this cylinder is pi r squared h as well. Now, if the cylinder, we call it a disk, okay? And disk is something that we are going to use today to find the actual volume of a solid. So let's say you have a region here which is bounded by y equals x squared and x equals 2, which is a vertical line, and the x-axis. Okay, so area bounded by y equals x squared, x equals 2, the vertical line, and x-axis. So let me color in the region that we're looking for. So area bounded by those three lines is right here. That's the area. Okay? Again, bounded by y equals x squared, x equals 2, and the x-axis. Okay? Now let's say this region is going to revolve around the x-axis 360 degrees. Just imagine this region right here, the red region, is revolving x-axis 360 degrees. When he does that, it's going to create a solid that looks like this. Okay, this is x-axis, which we call it when a certain region is revolving about a line. That line, we call it the axis of rotation. Okay, so in this problem, the axis of rotation is x-axis because the area revolves about x-axis. Sometimes it could be y equals 4, y equals -2. It depends on the problem. So basically, when you get this solid right here, how are you going to find the volume of this solid? Now, this is not a cone, so you have a curve here. Now, recall, do you remember how do you find the area underneath the curve from A to B? Do you remember the method we used to approximate the actual area underneath the curve? That's right. We used a method called RAM, Rectangular Approximation Method. Basically, we used a small infinite number of rectangles. We broke it into infinite number of rectangles, and we found the area of each rectangle. And that's the whole idea of integral from A to B of f of x dx, where f of x represents the height and dx represents the width of a rectangle. Now, we are going to use a similar approach, but since this is a volume, we cannot use a rectangle. We are going to use a disk that we just talked about earlier. Okay? What we're going to do is we're going to create a bunch of disks here. Okay? So when we do that, when we find the volume of each disk and add them up from A to B, that's how we're going to find the volume of the solid. So basically what we're doing is we're adding up the volume of a disk, which is pi r squared. Now H is going to be dx in this case, not H, because that's the change in x value. Okay? A to B. That is the formula to find the volume of a disk. So let me explain this. Another way. Let's say you have a rectangle here. Let's say we have a rectangle. And this rectangle revolves about the x-axis. What happens when you do that? Well, you are going to create a disk. Okay? So this right here represents dx. That's the height of a cylinder or disk. And this right here, the distance from the axis of rotation to the curve, that is going to be your r. So basically what we're doing is, again, when you have a solid after the revolution, you are breaking it into a small disk, and then you are adding up the volumes of all the disks from A to B. So if you simplify this formula right here, that's a pi. We could take out the pi. Let me erase this. So you'll get a pi, an integral from A to B, r squared dx. And what's important is r is the distance from the axis of rotation to the curve. Okay? So r is the distance from the axis of rotation to the curve. So let's do an example here. This is example 2 from page 407 in your textbook. The area bounded by f of x, 2 plus x cosine x, and x equals -2, and x equals 2, and the x-axis is revolving about the x-axis. So can you just imagine, visualize, when this region right here, which is bounded by f of x equals -2, x equals 2, and the x-axis, if this thing revolves about the x-axis, 360 degrees, what kind of solid is it going to form? Well, let me try to draw it. It's going to create something like this. Okay? Where this is axis of rotation. In this example, the axis of rotation will be x-axis because the area revolves about x-axis. Now again, when you get a cross section, let's say you cut the volume of the solid vertically. Okay? Let's say you cut this volume vertically. The cross section will be a disk. And basically what we need to do is accumulate volume of a disk, which is from -2 to 2. And what is the r? Well, the r is from the distance. Remember, again, r is the distance from the axis of rotation, in this case, x-axis, to the curve. So what is that distance right there, r? Well, that's just f of x, isn't it? That's the y value. In this case, it's going to be 2 plus x cosine x square. And what is our height? Well, that's dx. Well, once you set this up, oh, by the way, I forgot one thing. You got to have pi. Once you set this setup, all you got to do is now use your calculator to evaluate this. Now, let's do an example where the axis of rotation is not x-axis. So, for example, in this example, the region is bounded by y equals x squared. Let me use a different color here. And then y equals 4 and y-axis. So we're talking about this region right here. Now this region will be revolving about y equals 4 now, 360 degrees. Okay, so in this case, our axis of rotation will be y equals 4, not x-axis. Is revolving about y equals 4. So when you rotate that region about y equals 4, it will look like something like this. Now you got to use your imagination. Okay? Now when you get a cross section, let's say you cut this, you get a slice. Your cross section is again, what is it? It's a disk. And now by this time, you guys should realize why we call it a disk method. Okay? So now, how do you find the volume of this solid? How do you find this volume? Well, first of all, what is A? Our A is going to be 0. And what is going to be our B? Where do they intersect? 4 equals x squared. X is going to be positive -2. But we're talking about first quadrant. So x will be 2, not -2. Okay? So it will be pi and 0 to 2. Now, what's going to be our r? R is going to be this. Remember, what is r again? R is the axis of rotation, which is y equals 4, to the curve. Where's the curve? Right here. This is what we need to look for. That is going to be our r. Now, how do you get that? Well, the total distance from here to here is going to be y equals 4. So our r is going to be 4 minus, what is the distance of here, of this? Well, that's x squared. So in this case, our r is going to be 4 minus x squared. Okay? So it's going to be 4, quantity 4 minus x squared, and again, what is our height? That's dx. Again, we're using the formula pi integral from a to b, r squared dx. So once you have the setup, again, you may use your calculator to find the answer, and that's how you find the volume of a solid, of a revolution. Now the key is this: the r is the distance from an axis of rotation to the curve. Okay? Thanks for watching.